Welcome back for a 6 Caillou challenge. This is called Word A10, where A10 stands for abbreviation. So basically, you are going to be given a string of input, and it will have a sequence of words, perhaps with punctuation inserted as well. And your job is to find any word that contains 4 letters or more and sort of abbreviate it using this style where you use the first and last letters of the word, and then you say how many of the middle letters were cut out. So if you would count abbreviation, you got the A for the start of the word, the N for the end of the word, and the 10 would be that there's 10 letters between the A and the N. So hopefully that makes sense. I won't read this to you. You know how to read. Feel free to pause the video and stop and make sure you understand what's being asked of you if you would like. They have an example down here with elephant rides. Otherwise, come on back when you're ready and unpause and we'll step through a solution. Okay, we're back, and I think it makes sense to sort of develop a plan for how we're going to attack this, right? I like to organize my thoughts that way. So to that end, we are going to, there we go. All right, so we are going to develop a strategy, right? I tell people not to do too many mental gymnastics in your head. If you find yourself doing that and thinking too hard, just take the time to, even if it's a piece of paper, sketch out a little plan, or in this case, we'll do it in a Google Docs. So, we're going to have a string of input, and we're going to start by sort of converting this into a collection of what we'd call tokens, which is just a string array where it breaks up all of the input. It will separate it by space by default, and then we have a bunch of these globs or tokens to sort of analyze. And then you can imagine for each token in our tokens collection that we create, each token is going to come down to basically, we could think of them in just 2 cases. We can reduce everything to that. Case 1 would be where the token contains no punctuation. It contains no punctuation, right? And case 2 means it does, we'll say. It does contain punctuation. So like in the example, they had elephant rides, right? I think there was one where it ended in well with a period, technically that has punctuation too, and a regular word might be the, or, anything that has no punctuation in. So everything we encounter falls into these 2 cases, and since there's only 2 cases, then we sort of just figure out how to proceed in each of those 2 cases. And if we handle the only 2 possible cases, we have a complete solution. That's sort of the idea. It's very common to break problems down this way. So we'll say case 1, what do you do? Well, this is our easiest, this is our trivial case. So we'll say if the length, I'm just doing pseudocode here, this is an actual programming language. If the length is less than 4, that's what they said in the rules, return the token as is, right? We're going to sort of construct output, and we'll just append this token to the output that we're building. Else abbreviate it, I'll say. And again, it's according to those rules where you put the number in the middle of the first and last letter. Pretty simple, right? Case 2, now that we're dealing with when the token has some punctuation, we'll say we're going to sort of loop over the token, right? For each character in the token, we're going to do something. We're going to say, to start, let's gather all of the letter characters until we hit a punctuation mark, right? Gather letters until you hit I'll call it a non-letter. So it could be a number, punctuation, or really any symbol, just something that's not a letter. And that'll work for this challenge. We don't have to specifically search for some set of exact punctuation marks. I'll put punctuation in parentheses. So gather letters, we're going to keep building this up. So like with well, we'd get the W, we'd get the E, we'd get the L, we'd get the L, and then we'd hit the period there. So we gather up these letters. If the letters you've collected are 4 or longer, abbreviate it, right? And remember, this would be pure letters at this point, so we could basically handle it the same as case 1, abbreviating. If the letters you've collected are 4 or longer, then we're going to abbreviate it. I'll say else not. We're just going to pass it as is. There's nothing to abbreviate per the rules. We'll say append your word, this sort of these letters that we've been gathering. I'll call it a word. Append your word and the punctuation mark to the output that we're constructing as we go. I'll just make a note to add spaces when necessary. There's supposed to be spaces between each of the words. Just make a note for us to remember that. Clear the word you were building, right? Once we hit that punctuation mark, we've sort of gotten the bit that we can add to our output. Then we sort of need to reset this process, right? We wouldn't want to, after we did WELL period, we wouldn't want to keep that in the word anymore, right? Then we'd just keep adding letters to the previous output. So that's why we're clearing word. It's like a little state reset, right? And we continue for the next word that we're gonna obtain and possibly abbreviate. And continue to the next punctuation mark or end of the token. I'll try to keep this on one line here. And then finally, if any word has been built up at the end, don't forget to append that as well, right? Because imagine we had one where it didn't end in a punctuation mark, right? So normally the punctuation marks are sort of our trigger for processing the input we've gathered, and we would never really hit that sort of processing thing. So just be sure to grab whatever letters you have at the end and add that to the output, possibly abbreviating it as well as necessary. And really that's what it comes down to. I mean, we can make some methods to abbreviate words, perhaps one for words with punctuation and one without. So this is the idea here. Again, this is good to do. It doesn't really make sense to go coding right away if you don't really have an understanding of what you're doing, what you're trying to accomplish, right? You can get away with it with small problems, but you'll see that you're basically doing the same thing we just did now, but you're just mixing it in while you're typing it on a keyboard. So that's good. We have a plan. We can refer back to this as we code as necessary. So we'll hop back over to the challenge here. And we wanted to start, we said, I'll get rid of this returns that we don't need. We'll say we wanted to split it into tokens to start, right? So we'd say string array tokens equals input split. If you remember, the string class has a split method, right? Okay. And then I talked about how we are going to sort of build the output in place as we process the tokens, right? So to that end, I'm going to add a string builder. If you've been with me, you've seen this before. And I'll initialize this to a new string builder. I believe we need to bring in the system text class to use this. So I'll say using system text. Remember, we didn't make string builder, so I have to refer to where it's defined, so it can be found where it's defined. Good. And we'll build this as we go. So then the idea, like we said, we have this collection of tokens, and we'll say for each, let's call it string word in tokens. We'll call them words. You can use whatever variable name you want. And I've created a scope here. And then we'll sort of, well, let's build this out so you can see this sort of as it happens. I'll just start by saying int length equals word.length. We know strings have a length property. And then we'll add some print statements here just so you can see what's going on. We'll say word has length. And this will just give you an idea of what the input looks like. We're going to need a return statement. So we'll say return result to string. String builders have a toString property that will match what the method's expecting. Now, obviously this won't work, but we're just going to hit it so you can kind of see me as we're developing this. Oh, console does not exist, so you've probably hit that before. We need the system namespace for console. Again, we didn't define console, so that's totally fair for them to say we can't find that. Okay, good. Don't worry about the failures, but what I want to show you is our output here, right? So you can see this first test, which is even visible down here in the sample tests. You could see it broke it up into my period, dog comma, isn't, feeling, very, and well period. Notice well period, it's a length 5, right? So some of these have punctuation mixed in, so we're going to handle that, okay? So this was just to sort of see the input, and we can watch it as we're developing in case there's any confusion. So what I'll say is for each token, right, we're going to have it go like this. If the length is less than 4, we're going to say result append. You use the append method that's provided by String Builder, and we're going to say just append the word, right? There's no abbreviation that has to happen with a word of that size, again, per the rules. All right, so otherwise, we're dealing with something where the length is eligible for, or I should say it's required to abbreviate. So I'll say, let's check if it's, remember those two cases we defined in our plan. We said it either has punctuation or it doesn't. So this is our chance to define those two cases. A way we can do that is using a link method. This is 6 Caillou Challenge, so I assume you've seen me use link. I'm not going to go into great depth about that as I have in other videos, but you know where to find me if you have questions. All char is letter char. No. Word all. We're going to pass ch as the variable name for a character. And we'll say, we'll use the char class is letter method to check to make sure that everything, sorry, not a semicolon, to check that everything in the word that we're evaluating at the moment is a letter, if they're all a letter. If this encounters anything that's not a letter, it can stop. And if that's the case, we're going to say result append. There's no punctuation to worry about, but we do have to abbreviate. So I know we haven't made this yet, but I'm just going to pretend we have a method called abbreviate word that we can use to abbreviate properly. And then finally, we have that case 2 we were talking about where, and you know, I don't have to add any clause here to check. We know that if not all of the letters are, if not all the characters are letters, that there is punctuation present. So this else case captures everything else. We'll say result append. We talked about making, let's call it abbrev word with punc. We'll make a second method that can possibly use the first two, but we'll define these two methods. If you had a team, your team could be, you guys could have agreed in advance about these methods. Someone else could be working on those while I was working on this. And then that's it. I mean, it's appending the right output for each of the cases we had, and we will return that. But of course, we're not done here. Before we implement our two methods too, another best practice is we can do something like this. We can say private static read only int, we'll call it abbreviate length equals 4. And then we can use this constant instead of a magic number here, because when someone else comes and looks at our code, they don't understand necessarily what this 4 is. Why did someone use 4 here? If I give a meaningful name to it, then it makes it more apparent that there's some kind of threshold here. This is defined. This is part of our logic here. And then when you have to update the value, you can do it in one place. That's the other big benefit of that. But anyway, we do have to provide these abbreviate methods. Again, these can be private. This is sort of the internal workings of our class. We'll say private static string abbreviate word, we called the first one, and word. Again, this is going to assume that there's no punctuation involved whatsoever. Alternatively, you could have made one abbreviate word method and did the punctuation checking within that method, you know, tomato, tomato, right? This is the way that I'm doing it for whatever. You can add this part or not. If word dot length is less than abbreviate length, we'll just say return the word as it is. Don't do any processing. Otherwise, you're going to return string concat, which is just short. The string class offers us an ability to concatenate. We'll say words index 0, which is just the first letter, right? Then we'll say word dot length -2, right? Because we're condensing all of the letters between the first and the last letter. That's 2 of the letters of the word, right? The first and the last make 2. That's why we're subtracting 2 and taking the rest of the length. And then finally, word at index word length -1. Remember, we have to -1 because indices are 0 based. We would overrun if we didn't have that -1. So this is just saying the first letter, a number representing the length of the word besides those first 2 characters, and then the final letter of the word. Pretty easy, right? That was sort of our trivial case. And then we have a method called private static string. We'll say abbrev word with punc. This one can include punctuation with it. It's meant to handle that case specifically. So we'll define a scope for that. Our word with punctuation, we're going to say string result that we're going to sort of build up, right? Just like we described in our write-up in our doc. We're going to have this output that we're building that we keep appending to, right? And again, you could use a string builder here too if you want. That's probably the accurate thing to do. I'll use string here just so you can see that you can use string as well. You would care about this in a scenario where there were lots of appending. Remember with strings that they're being created anew each time you modify them. So just a little knowledge of what happens under the hood. And then we'll say string, we'll make a variable called current word that we could sort of collect the letters that we're processing, and I'll initialize that to nothing to start. I should say the empty string. Like we said, we're going to iterate over the word. So I'll say int I equals 0, I is less than word length, and ++ increment I, your standard for loop, right? And then, like we described, we're going to have 2 cases here, right? We're going to keep collecting letters to start, and then we are going to stop when we hit a punctuation character. So let's say if char is letter, word I, that's the current letter that we're looking at, right? It's going to start at the first letter. If it's a letter, we're going to say current word plus equals word I. We're going to say, hey, just add that letter to this current word thing. We're going to keep building it, right? And if you hit another letter through the next time through the loop, add that letter too, and keep going and going and going until you hit a punctuation mark. And then we got to cover when we eventually hit the punctuation mark, which should absolutely happen in this method as long as it's being used appropriately. This is meant for punctuation. So when you hit that, we'll say result plus equals. Remember, we're going to add our current word, but our current word could potentially need to be abbreviated, right? So not just the current word, we'll say abbreviate word current word. So it gets that as needed. And then we saw from elephant rides in the example, if you recall, that it wanted us to preserve the punctuation marks too. So let's be sure to add that as well. Plus word I, which is the current character, which is a punctuation mark. That's how we got in the else case, right? Good. And then, as mentioned, let's be sure to clear out current word so it doesn't continue appending the same letters. You know what I mean? We want a fresh start for the new set of letters that we will encounter. So we're going to clear that current word out. And then remember, it's quite possible that we end without a punctuation mark, which never triggers the last current word. So let's be sure at the very end we say, if not the string class has is null or empty, which just means that current word has something in it, some letters in it. We don't want to just forget it. We're going to say result plus equals abbreviate word current word. And then finally we should be able to just return the result. Something like that I think will work here. There's one thing I forgot here. We didn't handle the spaces. So in abbreviate, what I think we should do, well, you know what, I can run this so you can see what happens. Let's do a run. We haven't run in a while. And it's entirely possible I made some mistakes too. So we'll hit another attempt. Okay, line 19. This is good. You know, stupid errors on my part, but it's good practice. Line 19. Let's go there. Else if word all. Yep, sure. I'm missing one parenthesis. Did you see that? I had the one closing this. I had the one closing this, the all method, but I didn't have the one enclosing the condition there. So that's fair. 28. What's going on in line 28? Oh, static. There's no static. There's static. Sorry if you probably saw that and were yelling at me. We got line 30 problems. Identifier. Oh, yep. I see what I did. We didn't put the type with our parameter. Should be a string there. And then finally on line 38, I did the same thing. So my apologies. Good job if you caught that and were yelling at me. So let's see, get an updated list of errors or some output. Okay, good. We even passed some, right? But we still have some problems. And this is kind of what I was talking about with the spacing. So you can see we passed, but then we hit this test failed and it said expected my dog isn't feeling very well with the code. And it shows what we actually returned, which was, if you look at it, it's actually right, looks like, but we didn't put spaces in like they did. So that's sort of what I was talking about before. In a way we can handle that is back in our main method, sort of before we do anything, we can say if result.length, string builder has a length property too. If it's not equal to 0, that means that some word has already been appended to it. Then we'll say result append a space, right? If the result is not empty, we're going to add a space before we even get to adding whatever word comes next, right? And I added this check to make sure that we don't start with a space. We don't want a leading space before we do anything, right? We want our first word, and then after our first word's established, we want to put spaces before we add any more words. There are other ways that you could have included the spaces. That's just what came to mind. So let's try this to see if it fixes our problem. And we have all green, so it looks like we're clear. You're welcome to expand any of these if you like. You could have added more output, but I think you understand at this point. But yeah, I'm going to clean mine up a little bit. So for example, we don't need this stuff anymore, right? Well, length we use, but we don't need our print statement. What else do I have in here that's bogus? I could just replace length with, we could do it like this. Oops, let me undo. I meant to cut could paste that. Then we don't need length anymore either, right? Anything else that we don't really need? I don't think, oh, you know what? I should have just deleted these. I don't know why I commented them. Let's delete that. Good. Something like this. I'm gonna make this attempt again. Good. I'll submit mine like this. Yeah, so you know what to do if you have any questions. I appreciate you watching. I appreciate the likes and subs. That keeps me generating content. And I will see you in another video. Thank you. Remember, you can look at other people's solutions as well. You don't have to learn just from me. Check out what other people did and see what you can learn. There's a nice short solution. Until the next time, see ya.